When you look up at the night sky, it feels vast. You see thousands of stars. Human eyes cannot process the actual scale of reality. What we see from Earth is a microscopic fraction of the cosmos. The absolute limit of our vision, the observable universe, is a bubble roughly 93 billion light-years across. That boundary represents all the light that has had enough time to reach us since the Big Bang, and we have no reason to believe space stops there. This geometric model shows a flat plane of space-time. Because measurements of the cosmic background radiation show our local patch is extremely flat, the physical universe likely extends infinitely far beyond our visual horizon. We are infinitesimally small, sitting in an endlessly dark, expanding theater, and we can only ever see the brightly lit portion of the stage. But even that staggering 93 billion light-year expanse is overwhelmingly empty. Every star, planet, galaxy, and human being, everything we can interact with, accounts for roughly 5% of the mass and energy in the universe. About 27% of the cosmos is made of dark matter. It is a mysterious, invisible scaffolding that does not emit or absorb light. We cannot see it. We only know it exists because of the heavy gravitational pull it exerts on the matter we can see. This map of the bullet cluster shows exactly how immense that hidden gravity is. Pink areas show normal visible matter, like hot gas. Blue areas map where the actual gravitational mass is concentrated. This proves a massive, unseen substance acts as the cosmic glue. Most of our universe operates on a hidden architecture. We live in a house where we can only perceive the paint on the walls, completely blind to the actual structural beams holding the roof up. And where matter is visible, it can collapse into lethal extremes. When giant stars die, their mass compacts down until the local gravity becomes infinite, tearing a hole in space-time to form a black hole. This image captures the glowing gas swirling right at the edge of a black hole, known as the event horizon. This is a strict one-way boundary. According to Einstein's special relativity, the speed of light is an absolute limit. Once an object crosses the event horizon, the velocity required to escape exceeds the speed of light, guaranteeing that nothing can ever return. The gravity at this edge is so powerful it physically bends the flow of time. If you hovered near that boundary, your clock would tick slower relative to the rest of the universe. Time dilation physically pushes you forward into the future, while the physics of causality prevent any travel backward. We share our cosmic environment with literal physical traps. They are localized zones where the basic rules of time, motion, and human survival cease to function. Far away from those extremes, we are searching for something fragile. Out of all the billions of galaxies, Earth remains the only confirmed home for life. Statistically, that isolation is highly improbable. Astronomers have already cataloged thousands of exoplanets orbiting distant stars, many of them rocky, Earth-sized worlds, sitting squarely in habitable zones where liquid water can exist. To find out if any of those planets are occupied, we rely on the massive golden hexagonal mirrors of the James Webb Space Telescope. Astronomers point these instruments at specific targets, like exoplanet K2-18b, hunting for biosignature gases that are produced by living organisms. This visualization shows how that detection works. By capturing a tiny beam of starlight passing through an alien atmosphere, astronomers can split it into distinct chemical lines. It creates a specific barcode that reveals exactly which molecules are floating in the air of a world trillions of miles away. The cosmos is infinitely large, mostly invisible, and filled with hostile physics. Yet, we are meticulously scanning the dark, hoping to catch a single chemical signal proving we aren't alone. To truly understand our place in that dark, we actually have to look inward. We have to pull the camera all the way back from the edges of the universe, right down into the atomic structure of the human body. Shortly after the Big Bang, the universe was incredibly simple. It contained almost exclusively basic lightweight elements, hydrogen and helium. This animation demonstrates stellar nucleosynthesis. Inside ancient stars, crushing gravity forced simple atoms to collide and fuse, building heavy elements like carbon, oxygen, and iron. When those stars exhausted their fuel, their cores collapsed, detonating in massive supernovas that scattered these elements into space. Over millions of years, those drifting clouds of stellar debris crossed the void. Eventually, gravity pulled that heavy material together to form dense, rocky planets. One of those cooling rocky bodies was Earth, possessing the exact heavy chemical mixture required to spark biological life. The calcium in your bones, the iron in your blood, and the oxygen in your lungs were not created here. They were forged under extreme pressure inside the core of a dying star that exploded billions of years before our solar system even formed. We are not isolated observers standing separate from a cold, distant void. We are entirely built from cosmic debris. Humanity is the universe's own matter, cooled, compressed, and evolved over billions of years, finally waking up to look back at itself.